Alright guys, here we go, lesson 8.2, getting into our next conic section, which is the ellipse. So one thing you'll notice about the ellipse kind of right off the bat is looks very similar to the equation of a circle. We know that an ellipse is basically like an oval, right? So very similar to a circle, it's just not perfectly round. So here's kind of what creates that situation is we know in a circle, remember this was like x squared plus y squared equals r squared if it was a circle. Well, if it's a circle and it's perfectly round, that means the center of that circle is equidistant to every single point on that circle. Well, when these numbers are no longer the same, then it's no longer perfectly equidistant from the center. Because as I look at this, that 4 is going to cause me to travel a certain amount left and right, and that 25 is going to cause me to travel a certain amount up and down. And so if I'm not traveling the same value in all directions, then I'm not going to get a perfect circle. So anytime we see that these two numbers are different, then we know it's not a circle. Let's just say that that was a 4 and that was a 4. Then we would have a circle. But because that's not the case, because they're different values, it's like a skewed circle, and that's where we get the ellipse. Let me first take you to page 574 and 575 in your textbook. I want to show you a couple boxes of information that you guys should be looking at. So here's some good vocab on page 574. Here's a good look of the ellipse. So obviously not a perfect circle, so it's like more of an oval shape. So one of the things we're going to see with the ellipse, because it's more like an oval, is there is going to be sort of a major axis, which would be the longest portion of that oval through the center, and then there's going to be a minor axis, which would be the shortest axis through the center of that oval. So they do call the major axis the focal axis, because your foci, your two focus points, are going to be always on that major axis. So they'll often refer to it as the focal axis. So that's what you're seeing right here. So I often call it the major axis because that's what I was used to from other textbooks. That's what they call it. So I'll kind of give it both names. So it's the major axis or it's the focal axis, but same thing really. So yeah, the word foci is the plural for when you have more than one focus. So when we were doing the parabola, right, there was only one focus, so that's all we had to deal with. But when you're doing the ellipse, you have two of those guys. They're always inside of the ellipse, and they're always on the major axis, which is why they call it the focal axis. The other two key points that we're going to be looking at here would be the two vertices. So also on the major axis, you get the two vertices. So these are just simply 2 points on the ellipse, and they're the same distance, equidistant from the center. If you've seen these in other textbooks, they might refer you to this point right here and this point right here as co-vertices. We don't often deal with those unless we're trying to make the graph. And so those aren't really points that you would be asked for, but I'm going to show you how we can identify them because they would help us draw a graph. What's what we call the co-vertices are the ones that are found on the minor axis. Right, and so that's what's going on right here. So they don't explain all that in here, but that's what you would see depending on which textbook you were using to work on the ellipse. So those are like the main points. So whenever you're asked to find information about an ellipse, those are all the main things that you're going to be asked for. You're going to be asked to identify the center, the two foci, and the two vertices of that ellipse. Let me take you to the formulas. So on page 575, you're going to see this blue box right here, and this is going to have all the important information regarding the formulas for the ellipse. So one big difference about this than the circle is they don't want this to equal r squared because there really is no radius. So instead, the standard form of the ellipse always equals 1. So it's always going to be set equal to 1. So we're always looking at these two denominators for kind of our important information here. The bigger of the two, they will call the A value. The smaller of the two, they would call the B value. One of the things that they like to do, as you look at both of these formulas, is they like to put the A value, the larger one, in front. So if your major axis is running left and right, you're going to see this look right here. If your major axis or your focal axis is running up and down, you're going to see this look right here. It really wouldn't matter because these are separated by a plus sign, so we could switch the order on this and it wouldn't matter. This is just the way this book does it, so that's the way we're going to do it. And so as we look at these, again, they're always going to put the larger term first. If this number represents a squared, well, if you square root it, you would get your a value. The a value tells you how far you travel. Here's a good look right here. The a value tells you how far you travel from the center to a vertex, whether it's to the left or to the right, or in this look right here, it would be up or down. The b value, which if you took the square root of the smaller number, is going to tell you how far you would travel up or down or left or right on the minor axis to get your, what I would call the co-vertices. Even though those aren't really identified here, other books would call them the co-vertices. And again, we don't really identify them other than they just help us make the graph when we're going to graph it. The one last thing is how do you find the foci, and that's going to be using this formula right here. So it's really basically the Pythagorean theorem is where that comes from. Obviously, you'll see that relationship. But it's a little different as far as a, b, and c, right? Because it's not a squared plus b squared equals c squared, right? They're calling the two different terms for b and c. So we'll take a look at that, though, when we do a practice problem. But I wanted you to at least see what that looks like. So let's go through. Let me just quickly explain theirs, and then I want to go through one from start to finish with you. So as you look at this setup right here, remember they want these to equal 1, not 100. So what they did on this is they said, okay, let's divide everything by 100. So I can make the right side of this equation equal 1. So we would always divide everything by whatever this is in order to make it equal 1. Well, if you reduce those fractions, you're going to get this look right here. So you're going to have x squared over 25 plus y squared over 4 equals 1. Notice they put the larger term first and the smaller one second. So a couple things we're going to get out of this one is because the larger term is attached to the x, I know that this ellipse is going to be bigger left and right, and it's going to be smaller as I go up and down, which tells me that my major axis, my focal axis, is going to be to the left and to the right. It's horizontal. So a couple things we said was some key points. If I square root this, obviously the square root of 25 is 5. So I would travel 5 to the left and to the right to get my vertices. If I square root that, my b value is 2. So I would travel 2 units up and down from the center to get my co-vertices. And if I took my a squared and my b squared and plugged them into that formula that we were just looking at, that's going to tell me, where'd it go? That's going to tell me what my foci are. So we do always write all this information down as ordered pairs because they are points on the graph. And as far as the foci are concerned, just keep in mind they're always on the major axis. So if my major axis or my focal axis is on the x, then I want to put that value into my x coordinate. Had this been a y squared and this was an x squared, then my foci would have gone in for the y coordinate. Let's go through one together. I just wanted you to see a little bit of the highlights, but I think it'll make more sense when we go through the entire problem. So first thing we do is we would start out by dividing everything here by 36 so that it would equal 1. So obviously if I had 9 over 36, that would become 1 over 4. 4 over 36 would become 1 over 9. And now it equals 1. So this would be a very acceptable way of writing this, But again, the one thing this book does is they always want this leading term, the biggest one, to be first. They want a squared to be first. So they would have you write it as y squared over 9 plus x squared over 4 equals 1. So they would write it this way. And this is actually not a bad way to do it, because this will help you when we get to the hyperbola in our next section. So, so we're going to look at it this way. So a couple things here. First of all, recognize that this is just y squared and this is just x squared. There's no pluses or minuses up there, which means this ellipse is centered at 0, 0. If we had like y plus or minus a number, or x plus or minus a number, then we would be shifting away from 0, 0 and we would be somewhere else. And you'll see that on the next page. So this is kind of the most basic one, where this is just x squared, that's just y squared, so I'm centered at 0, 0. So my center is 0, 0. Let's kind of graph this as we... I think it's always helpful to look at the graph on these as a good sort of visual. Even though you really don't have to graph this one, I think it helps to see where all the important information is going. So this one, from the center, from 0, 0, is going to travel 3 units up and down. So remember, this represents a squared. So if I square root it, that tells me my a value is 3. Let's just write that. And because it's attached to y, I know I travel up and down. So I'm going to go 3 units up and 3 units down, and that gives me my 2 vertices. And you should write those as ordered pairs. So in homework or like a test question, you would want to write your 2 vertices as 0, comma, plus or minus 3. The co-vertices, again, will just help you graph it, so I'm just doing it on here for visual. But if this is b squared, that means my b value is 2. And because it's attached to x, I would go 2 units to the right and 2 units to the left to get those 2 points that I call the co-vertices. So if I connect the dots here, and you're going to find out right away that my artwork is very bad, so don't judge me. Art was never my thing. All right. That's actually maybe the best ellipse I've ever drawn in my life. So anyway, so there's kind of the outline of the graph. We have our 2 vertices. We know the center's at 0, 0. The one other thing they would ask you to identify are the foci. So remember, for the foci, here's what I think is maybe the best way of writing it. I like what they did here. They made kind of an adjustment on the formula. And this is the way I've always seen it in other textbooks as well. So I would like to see, because I'm solving for C. C is the distance from the center to a focus point. So I like to isolate the C value. So I think it's best to see this formula as C squared equals A squared minus B squared. So as I plug these numbers in, well, here's A squared and here's B squared. So C squared equals 9 minus 4, which is obviously 5. So as I square root both sides, my C value is plus or minus, oops, I said 5 and wrote, I meant 4. I was seeing the answer in advance. So it should be 9 minus 4, sorry. So the difference is 5, obviously, so plus or minus root 5 is going to be our C value. So what that tells you is I have to travel up the square root of 5 to get this focus, and I have to travel down the square root of 5 to get that focus point. Do keep in mind that your foci are always, always, always on the major or focal axis. So I know they're going to be on the y-axis. So I need to travel up and down that amount. Don't ever write these as a decimal. Whenever you write these as ordered pairs, leave it as a radical. To figure out where it's going to go on the graph, you might want to look at it as a decimal, because otherwise you might have a hard time figuring out where the square root of 5 would go. Obviously, it's going to be about 2.1. So I know this focus would be about here. And if I go down 2.1, that one would be about there. So those are my two foci. But again, you'd only look at those as a decimal to help you graph them. Don't write them as decimals. So the last thing we would identify are the two foci, which are these guys. And that's it. Those are kind of the highlights of the ellipse. So let me take you to one that is not centered at 0, 0. So I already wrote the formula on this one. And we're going to graph this at the same time. I already have mine graphed down below because I had another video issue, and so I'd already done this, but I'm doing it again. So there was a lot more stuff here, but I just whited it out because I wanted you to see it as we go. When you shift away from 0, 0, so notice the difference now in this look right here. It's no longer x squared and y squared. All right, there's pluses and minuses thrown in, which is what shifts you away from 0, 0. So here's the equation that we're now looking at. It's really not any different other than you have h and k, which are going to tell you where the center is. If you want to see a little more information about this formula, you can look on page 577, but I'm going to give you the highlights right now. So as I look at, so one thing to keep in mind for this one is, remember, these minuses are already built into the formula, which means the number you see here, we're always kind of doing the opposite of what you would see. So this one is going to go 3 units up, and this is going to go 1 unit to the left. So our new center, no longer at 0, 0, is now going to be at -1, +3. So I got a grid down below, and I was graphing this as I went. So mine's already graphed, but you can kind of follow along by making your own graph. I'm trying to get all that on the screen for you. So there's our center. Always a great place to start. The major axis, or again, they refer to this as your focal axis. So either way, same thing. We always want to look to the larger value to identify that information. So if 16 represents a squared, that means our a value would be 4, right? Because I'm going to square root that to get my a value. I'm going to square root that to get my b value. And again, this tells you how far you're going to travel from the center to get your vertices. And this tells you how far you would travel from the center to get your co-vertices. So I need to travel 4 units. And in this case, my vertices are attached to the y value, so I need to go up or down 4 units from the center. So I just started right here at the center. I went up 4, and I got that vertex. And then from here, I went down 4 to get that vertex. So my focal axis is a total of 8 units, right? So, but again, this value tells me to go where to go from the center to get my vertices. Just as a quick side note, you do not have to graph this in order to identify these coordinates, right? I mean, I did it by looking at the graph, but if I recognize that I'm going to go 4 units up or down from here, well, that simply means I'm going to add 4 to my y-coordinate, and I'm going to subtract 4 from my y-coordinate in order to get my vertices. So we certainly could have just looked at that point and said, well, if I added 4, it goes up to 7, and if I subtract 4, it's at -1. And that's where they are on my graph, but we can do it either way. Some people are more visual and will do better by looking at a graph, and some people can just kind of stick with the formulas and the numbers and apply them that way. So the minor axis, your co-vertices, again, this really is not something you're going to be asked for. It just helps make the graph. So anytime you're asked to graph, you want to find this information just to make the graph, right? That's kind of what it's used for. So again, this tells me I'm going to travel 2 units, and it's attached to x, so I'm going to travel 2 units left and right to get my co-vertices. So I plotted those 2 points right there. That helped me make the graph. And that's where my video cut out. So that's where I am. So we can just write those down. But again, I could do the same thing for this. If I know that I'm going to travel 2 units left and right from here, I could simply add 2 to my x and subtract 2 from my x to identify those coordinates. We'll just write them down. All right, and then the last thing we're going to always be asked to find on these are the foci. So remember the formula we're looking at is c squared equals a squared minus b squared. So there's our setup, a squared, b squared. So I know c squared is 12. So if I square root that, c value would be plus or minus the square root of 12, which we could simplify to be 2 root 3. So we should be simplifying those as radicals, and we should be leaving them like this. As far as putting them on the graph and as far as writing them as ordered pairs, kind of two different approaches here. As far as just writing it as an ordered pair, I can use the same trick that I was talking about with my center. So remember, my focal axis right now is going to go up or down. So all I'm going to simply do is I'm going to take this information and attach it to my y coordinate of the center, because it's going to go up 2 rad 3 and down 2 rad 3 from here. So I can simply attach that to the y coordinate and say 3 plus or minus 2 rad 3. And so that's kind of the most appropriate way to write coordinates of the foci. Putting them on the graph is a different story, right? So the square root of 12 would be like 3.5-ish, right? So if I put that into a calculator, it's about 3.5. That at least gives me a gauge. 1, 2, 3.5 is about where those should go. And down 3.5. Those will always be on the interior of the ellipse, and they will always be on the major axis. That's why they call it the focal axis. So let me flip over to these guys. Kind of more fun with the ellipse here. The difference on this is now they're going to give you some certain information, kind of like what we did with the parabola. And we have to use that information to develop the formula that we see here. So on this one, they are giving us the two vertices, because it's calling them the endpoints of the major axis, which we know are the vertices, right? So those are my vertices, and the minor axis has a length of 4. So they kind of already plotted those right here, which I'm super glad they did, because sorry, I was drawing and thinking at the same time. When you do this type of problem, I always recommend sketching the information to help kind of get all the numbers right. So this is the picture that they are painting for us. So here's what we want to identify. The first thing I would do on this, and I'm glad they did this too, is as soon as I can tell that the major axis is going left and right, then this is the formula I would write down. I would write the formula, because from here, now I can look at those and just start finding the pieces that I need. I know that H and K are going to come from the center. I know to find these two guys based on the distance I'm traveling from the center. So that's what we're going to get all that information from. But I think it helps to sketch, write the formula, and then start plugging in the numbers. So let's just start with the center for H and K. We can get H and K by simply finding the midpoint of our two vertices. So if we add those guys up and divide by 2, then that's where we would get this value right here. So 6 is going to get subbed in for H, 1 is going to get subbed in for K, and we already know the center. So that's where this and this came from. As far as those guys, all we have to do is really count. If I'm going from here, from the center to a vertex, either one, I'm seeing that as a distance of 4 units. And the distance I'm going to travel from the center to a co-vertex, either one, whether it's the top one or the bottom one, is a distance of 2. So that makes 4 my A value and 2 my B value. Well, we want to write those as A squared and B squared. So that's where we're getting the 16 and the 4. So not so bad, but again, I do think it helps to sketch. So let's do one of those together. And I already kind of laid out what I would do if I was you on sketching out one of these guys. So first thing I would do is, let's do a quick sketch on the information that they're giving me. That's going to help me pick which formula I should be looking at. So let's see, for number 8, the minor axis, so now they're giving me the co-vertices, are at 0, 0 and 0, 4. So those are my co-vertices, right? Which means if those are the co-vertices, I know my ellipse is going to look something like this, because if this is the minor axis, then my major axis must go this way. So because my major axis is going left and right, I know my x should go first and my y should go second. So here's the formula. Again, all I'm going to do is plug in the numbers. So as I look at the center, remember the center is going to be the midpoint of your vertices. Whether it's the real vertices or the co-vertices, the center is still the center of those points. So again, if I were to find the midpoint, now if I'm looking at a graph, that's real easy. It's right here. At 0, 2, right? There's the center. If you weren't looking at a graph, you just do your basic algebra, right? I would add those up and divide by 2. And I'm still going to get the point 0, 2 as my center. So let's say, I guess I don't need to write x minus 0 squared. You certainly could, but we don't need to do that. So if it's 0, let's just call it x squared. Two is my y coordinate, so y minus 2 is going in for that one. So here is my center. So the other thing they told us is that the length of the major axis is 8. So if I went 4 units that way and 4 units that way, I would have the major axis, and then so now I can kind of see my ellipse taking shape here. So I know it's going to look something like that. As far as identifying a squared and b squared, remember your distance from the center to a vertex is a. So it's 4 units to get to a. If this represents a squared, then I'm going to write it as 16. 2 units is my b value, so 2 squared would go here, and that's it. That would be our equation. All right, let me jump down to this one. This one's very similar to what we've already done. This is really review. What I was going to show you on this one, though, is you could certainly do it without looking at the graph, right? I recommend graphing it. I graph them because I think visually that really helps me, but you don't have to. As I pull out the important information from this, first things first, they did kind of flip the order on us here. Really the appropriate way, according to the book, the way that they would typically write this is they would put him first because he's bigger. You don't have to. That's just kind of the way this book has tended to do it, although they're kind of breaking their own rule in this example, but that's okay. We can still pull out the important information here. So my center, -3, +4. I would write that first because all the information you get after that is going to come from this point. So -3, 4 is the center. So notice all they had to do to get the vertices, since my a value would be 5 and it's attached to y, I would add 5 and subtract 5 to this number, and I would get my vertices. The only other important piece you need to come up with would be the foci. So that's just coming from our formula that we've already worked on. The one thing I would tell you to remember on that one is, remember, if you're, whatever you're getting out of this, in this case it actually came out to be a nice clean number, just consider which value you should attach it to. As I look at this, remember, my major axis, my focal axis, is on the y. So I'm going to take that 3, which is my c value, and I'm going to add it to this 4 and subtract it from 4. And that's where they got the foci. Okay. Let me take you to kind of the end of this. And then this will be the last thing that we do here. Let me, I'm not going to read through all of this. It is actually worthy reading. It's kind of interesting. You might find it interesting, maybe in a sort of nerdy math kind of a way, but it is actually kind of interesting. I'm just going to show you a quick diagram. You can read it on your own. Eccentricity has to do with basically how off-center something is. So a lot of this goes back to things orbiting the sun, and they discovered that they don't orbit in a perfect circle. The orbit is an ellipse. So, and that goes with all things that orbit the sun. As they kind of describe all that within this paragraph and then more on the next page. So it was actually kind of interesting. Oh, so there's some up here too. But so that's where this comes from. The one thing that I'm just going to say right now is this is what you need to know to get the eccentricity of something is simply the ratio of c over a. And that's it. So that's very simple. When they ask you for eccentricity, it's just c over a. If you really want to know where that comes from and get a little more definition on that, take a look at those couple pages. It is actually kind of interesting. Okay. Last one. So this is, we're going to now find eccentricity. I wanted to throw it into this last problem here. So our goal on this, before we can find any information, is to put it in standard form. So we're going to use a little completing the square. So let's group our x terms together. So I got 3x squared minus 12x. And then we're going to group our y terms. So I got the 5y squared plus 30y. And then I'm going to take my constant and move it over to the other side. So we're going to get that negative 42 over here. So one of the issues that we have to deal with on this is if I want to be able to create a perfect square here by completing the square, I got to get that 3 out of the way. I'm going to have to do the same thing by getting this 5 out of the way before I complete the square. So with the x's, I'm going to divide out the 3 so that I can set it up for completing the square. Leave yourself some space to complete that square. Let's do the same thing with the 5. Is I'm going to pull out the 5, leaving me with y squared plus 6y. And then leave yourself some space to complete that square. So here is sort of the outline that I would get it to before trying to complete the square. Now, we've done these before, and you guys have seen these in the past, but remember, this was our little formula. Remember, this is A, this is B, this is C. We're trying to figure out what C is, and we use this little formula to do it. So if I took my negative 4, cut it in half, and squared it, I would get 4. On this one, if I took 6, cut it in half, and squared it, I would get 9. So now these are perfect squares. But here's the one thing you can't forget to do. Whatever you did to that left side, you got to also do to the right side. But what did we really just add right here? I didn't just add 4. I added 3 times 4, right? Because this 3 belongs to everything in parentheses. So I didn't really just add 4 to this side. I actually added 12. So I need to add 12 on this side as well. Let's do the same thing here. We can see we actually added 45. So add 45. And then now let's just clean this up a little bit. If he's a perfect square, we could now write him as x minus 2 quantity squared. All right, so the first piece looks like this. Let's do the same thing for this one. So if we were to put that into factors, we're looking at y plus 3 squared. If we combine terms over here, it looks like a total of 15. All right, so the one last step would be to divide everything by 15 so that we can get it into standard form. So it's going to look like this. So if we clean that up, so 3 over 15 is going to reduce. Same thing over here, that's going to reduce. And now it equals 1. So now you've put it in standard form. Now you can find anything they ask for. So as far as the vertices, so again, remember how we did that? If my center is 2, 3, then to get my vertices, I need to travel the square root of 5 left and right from the center. So I'm simply going to attach it onto the x coordinate. So I'm going to say 2 plus or minus root 5, comma 3. So that's where my vertices would go. So foci, again, you're just doing, remember it's c squared equals a squared minus b squared. So plus or minus root 2. And again, those are also going to attach to the x coordinate. Those foci will go wherever your vertices go. The one last thing we could find on here would be eccentricity. So remember, real simple ratio for eccentricity, it's just c over a. So on this one, recognize that my c value is root 2. So my c value is root 2. And my a value is root 5. And that's it. That would be our eccentricity. Of course, you could clean that up a little bit. You could rationalize the denominator to get the radical so it's not on bottom anymore, but I think you get the idea. So this is just a very simple little formula that we use to find eccentricity. But that is it for 8.2.